Hello student. Today we will discuss magnetic field due to current carrying circular loop on its axis. Here is the circular loop and here is the axis. That this one is x-axis. And this loop is circular and it is carrying current like this. The current is I and this current is coming on this loop and getting out like this. Because this current carrying loop, there will be a production of magnetic field around it. And we have to find out a magnetic field at the point P, which is situated on its axis at a distance x from its center. Here is the center. This is O. Now we will take a very small element here. That this element is A, B, C. This element is dl and the direction of dl is tangential and this is the direction of dl represented by red line arrow. This element dl is making angle with line of joining the point and element. The line of joining from point and element is PB. And this making angle dl is 90 degree. This is line of joining of element to the point P, and here is the element dl, and this is the angle between line of joining and element dl, and it is 90 degree. So the angle between dl and pb is equal to 90 degree. The current on loop is I. The length of element is dl. And magnetic field at this point P will be dB. And the magnetic field is perpendicular to the line of joining as well as with element dl. The dB is perpendicular to PB and perpendicular to dl. So using Biot-Savart law, we have equation dB is equal to mu naught by 4 pi I dl sine theta upon r square. This is in magnitude. So for this element A, B, C, the dV will be mu naught upon 4 pi I dl sine 90 degree upon PB square. The distance between element and P is PB. If the radius of this loop is A, A is the radius of loop, then from triangle O, B, P, PB square is equal to OB square plus OP square using Pythagoras theorem. So PB square is equal to x square plus A square. Right? So dB will be mu naught by 4 pi I dl upon x square plus A square. This is equation 1. Similarly, we may take the element A dash, B dash, C dash here, just opposite to the ABC. The dl element having direction dl, this one, and magnetic field will be dv dash from the triangle OB dash P, OB dash P, we will get again same magnitude of dv as dv dash. So dv dash will also equal to mu naught by 4 pi I dl upon x square plus A square. So this is our second equation. We take here element A, B, C, and just opposite A dash, B dash, C dash. And we were able to find out the value of dB and dV dash. The angle between DL and line of joining is 90 degree. Again here it will be 90 degree. Now if we take this angle as alpha, that is angle BPO, and it is equal to alpha, this angle. A congruent triangle PB dash O, the angle will also alpha here. It is equal to angle B dash PO. Now if we take the axis Y also here, we will have the component of dV toward x-axis and toward y-axis. Now this angle is alpha, then this will be 90 minus alpha. This will be 90 minus alpha. So this angle will also alpha. The component of dV toward y-axis will be dV cos alpha. The component toward y-axis is dV cos alpha along the angle alpha. And toward x-axis, it will be dV sin alpha. Similarly, the angle of dV dash from y-axis will be alpha. So component toward y-axis will be dV dash cos alpha, and toward x-axis it will be dV dash sin alpha. Now from equation 1 and 2, the magnitude of dV is equal to dV dash. So the magnetic field toward y-axis will be dV cos alpha minus dV dash cos alpha, because they are equal, so they will give the value as 0. So the component will cancel each other. But toward x-axis, the dV x is equal to dV sin alpha plus dV dash sin alpha. These are only because of the two elements, but there are number of elements we may take here also, just opposite here also. So we will have number of pairs of elements on this current carrying loop. So we will have a number of values in x-axis. In y-axis, the pair of these will cancel each other one by one. But in x-axis, they are regularly adding. So magnetic field toward x-axis will be equal to integration of dV sin alpha. It means we are adding the magnetic field component of each and every element of the circular loop, right? Now what we have, Bx is equal to integration of dV sine alpha, right? We will put the value of dV from equation 1. It is mu naught by 4 pi I dl upon x square plus a square into sine alpha. Now value of sine alpha, we have the triangle like this one. The value toward x-axis is x, and the radius of loop was a, and this was PB, and this angle was alpha. So sine alpha is equal to the perpendicular upon hypotenuse, and hypotenuse is equal to under root x square plus a square. So we are able to put the value of sine alpha in this equation. So Bx is equal to mu naught by 4 pi I dl upon x square plus a square into sine alpha, and the value of sine alpha is a upon under root x square plus a square. So magnetic field due to current carrying loop toward the x-axis, that is axis of current carrying loop, is equal to mu naught by 4 pi I, current is constant, radius is constant, the point position is constant, it is x, so it is x square plus a square to the power 3 by 2 and integration of dl. X square plus a square into under root x square plus a square becomes x square plus a square 3 by 2, 1.5, that is 3 by 2. The dl was the element on the loop. If we add all the element of the loop, what we will get? We will get the circumference of the circle, that is circular loop. And circumference of the circular loop is 2 pi radius, and radius is a. Hence, magnetic field due to current carrying loop on its axis becomes mu naught by 2 I a square upon x square plus a square to the power 3 by 2 Tesla.